Hi everyone, welcome to today's data analysis class. This presentation shows an example of stepwise regression, which as I show here is a variable selection procedure for independent variables that you believe to be the most essential in your final prediction equation. And this happens in a situation where you have a long list of explanatory variable that you think make sense, but you also know that there are simply too many of them to be included in your final model. A researcher is often interested in determining the best independent variable in any analysis simply because a researcher's goal is to come up with a parsimonious model which can still give them a good prediction equation but with fewest number of explanatory variable. To make this more relatable to you, I can let my y to be the price of house. Okay? Where else? What could possibly be our x1, x2, x3 and so many other independent variable here? To name a few, it can be the square feet of the house. What is the location of the house? How many rooms do you have? And what is the number of parking lots that you get? Is the house a leasehold or a freehold? What is the demographics of the area of your housing? And what is the interest rate that the bank will offer? There are so many, but when you are trying to study, you cannot be including everything. So now this stepwise regression consists of series of steps designed to find the most useful x variables to be included in a multiple regression model. Now why am I saying it's a multiple regression model? Because you have more than one independent variable. Now why are we comparing this with multiple regression model? So the next question that you want to ask yourself is, what is the difference between a multiple regression and a stepwise regression? In a standard multiple regression, all independent variable will be entered into the regression equation at once. Whereas in a stepwise regression, the independent variables are entered into the regression equation one at a time based upon a statistical criteria. See, let's try this again. At each step of the procedure, each x value is evaluated using a set criterion to see if it could remain in the model or not. And what is our basis of this set criterion? Usually it's very pretty common. It is the t value obtained from running our regression. Sometimes there are also researchers who use r square as the explanatory power. So the basis of selection could either be choosing a variable that satisfy the set criteria, or we can remove a variable that least satisfies our set criterion. So if you can recall your previous lessons of forward selection and backward selection, by now you should be able to sense some differences between this stepwise regression and your forward and backward regression. As we go through, let's identify all the differences. Stepwise methods are commonly used in psychological research or educational researches to evaluate the order of importance of variable and to select useful sets of variables, as stated by Thomson in 1995. Why is order important? Are you saying that I can't place the variables, the independent variables, in any random order? Does it even matter? If this is your question, then the answer is definitely the order does matter. Don't you think when you put a first independent variable, and then you place the second independent variable. This second independent variable can actually affect the coefficient of your first one. So we must have a logical flow of entering the variables. So what is this logical flow of entering the variables? The first variable with the highest explanatory power must be entered first, and then the second one will have the second most explanatory power, and then the third one will be having its best explanatory power. So if your selection of independent variable is such, then you can express the whole process in a more logical manner. It also says it involves developing a sequence of linear models through variables entry as determined by the computer algorithm. Of course, SPSS does make our life easy. That can be viewed as a variation of the forward selection method, since independent variables are entered one at a time. Let's pause for a while and then we look into the forward selection. Forward selection method is simple to define. You will begin with no independent variable in the model. You will select the variable that has the highest R squared. Okay, let's say you have x1, x2 and x3. Initially, you won't have any independent variable. Let's say if x2 happens to have the highest R squared variable, then you will select this first. So at each step, select the independent variable that increases R squared the most. And then you will stop adding variables when none of the remaining variables are significant. And what you have to be careful about this forward selection is, once a variable enters the model, then you cannot delete the variable anymore. If you have used SPSS, forward selection method is quite similar to the stepwise regression method. But of course, they are not identical. Else, there wouldn't be two names, right? However, true stepwise entry differs from forward entry in that at each step of a stepwise analysis, the removal of each entered independent variable is also considered. The difference is, in forward selection, you have only entering variables. There is no removing variables. So the entered predictors are deleted in subsequent steps if they no longer contribute a unique predictive power to the regression when considered in combination with newly entered independent variable. So if somebody were to ask you what is the difference between forward and stepwise, in forward, once entered, there is no more removing, whereas in stepwise, look at this point 4. If the independent variable no longer contribute or it has no significant values, then it will be removed in the next process of regression model. Let us look at an example of doing stepwise regression in SPSS. So I have my variable view here. My dependent variable is going to be years to graduate, and I have 4 independent variables, my predictor variables, namely mother's education level, father's education level, family's income, and the last one is faculty interaction. Let us check whether we have any missing values or not. I don't have. I'll show you my data view as usual. Let's check on the descriptive statistics first. Let us select all. I have 80 data each, the minimum value and my maximum values. uh, mean value to graduate is 5 years. Our standard deviation is 0.71. Okay, it looks good. Now let's go and analyze our regression. Or if you want to study the correlation, we can do that first. Bivariate Pearson's Spearman. Okay, let's check what does the correlation shows. When I look at the mother's education level, it is negative 0.825. We have another one here, faculty interaction with negative 0.834. Family income is negative 0.763. Father's education is not well correlated with the years to graduate. But if I look through in this row, it looks like the faculty interaction is having the highest correlation. Now, why do I have a negative value in front of the mother's education and the faculty, and all of it has a negative value here, right? What could be the reason? It's simply because it is a negative relationship. Assuming your mother is someone's mother is an educated person, and of course we expect the mother to contribute in the child's academic processes, and that's how the child is going to graduate earlier. They might not need 6 years to graduate, maybe they will complete within the given time. So negative indicates an inverse relationship, which is very much logical in this scenario. Okay, that is about the basic. Now let's see, where do we find the stepwise regression over here. You go to the regression, you go to your linear, and I have my dependent variable here. I have already input it earlier, and my independent, all the rest, it's here. The 4 variables are all here. Now the method I'm choosing is stepwise. Let's look at our statistics. If you want to include your descriptive, we've already done that. If you want to do it again, you can do so. And if you want to study your collinearity, it is also over there, and you can select and what gets removed. Yeah, look at this one here, your variable which is getting entered and removed. In the first model, the variable that got entered was faculty interaction, so I assume this had the highest t value or highly correlated, and it was clear why this was selected, because this has the highest correlation also. And then in my second model, what was included is the mother's education level, and in the third model I have faculty interaction, mother's education, and the family income. And in my last model I have all the above 1, 2, 3, and together with father's education. And let's look at this fifth model here. My faculty interaction got removed. Okay, this is our model 1. If you can look at this faculty interaction, and then in the second model we have faculty interaction and mother's education, so on. And look at the E. In the fifth model, you don't have faculty interaction. So the variable that was the best predictor initially, it got removed from the final model. This could be a problem with the stepwise regression. If you scroll down under the coefficient part, you can actually look at their t values. So faculty interaction initially had a t value of negative 13.355, and then in the second model it got reduced to negative 6.241. In the third model, negative 3.355. And in the fourth model, it's negative 1.216. So there is an improvement here, but still it got removed in the fifth model of ours. What could be the reason? Let's look at the significance value here. In the fourth model, the faculty interaction, it was not significant. So that means it got no effect to the dependent variable anymore. Faculty interaction shows that it is not affecting the years to graduate. That is why in the fifth model it is being removed. So what can we say about this? Has this model done any good? Can we say whether it has been good or not? We can't abruptly say whether it has done any good to our model or not. At least I know one thing, that the variable that was contributing highest is no more in my final model, surprisingly. So this is the problem with the stepwise regression sometimes. So whenever such a scenario happens, can we improvise on our model? Maybe this is not the best a regression to run. I mean, the whole idea was to find the best independent variable to be selected, but now it puts us in a doubt when what we were confident with has been removed. Based on what we have calculated in our SPSS for the stepwise regression, we can actually see this is our Y, the years to graduate, and then we had our X1, X2, X3, X4, namely mother's education, father's education, family income, and faculty interaction. If you look closely, the result showed that the faculty interest variable, independent variable, has been removed. What they are sustaining now is only the remaining three. So what could have actually happened, and how does this stepwise regression actually worked? Let's look at our model 1 here. The model 1 says they have selected faculty interaction as their first independent variable. So this is which was put into the system first. And how does SPSS calculated this? So the SPSS would have done this. They would have done run regression for y equal to x1, y equals to x2. They have run separately for all the four independent variable. Then they would have calculated the highest t value for all of these. So according to our model 1, it is evident that faculty interaction was chosen first. See, the faculty interaction was chosen here. So this has the most set criterion now. So maybe this was selected simply because it was highly correlated earlier. Then in the next model, in the model 2, when it ran again, it selected faculty interaction and also mother's education. So what could have happened once this has been selected? SPSS would have run another regression using x4 and x1, x4 and x2, x4 and x3. So in this combination, which one would have had the highest set criterion? And you know the answer, because model 2 says it was faculty interaction and mother's education. So we have selected, x1 is this. Yeah, this was selected. So this is out of the picture and this is also out of the picture. We have x4 and x1 now. So in the third time, what could have happened? The regression run by the SPSS would have been like this. It's x4 and x1, and then they would have tested with x2 now. x4, x1, and then x3. So when this was done, in the third selection, the family income, which is the x3, which got selected. So this is how the stepwise process is actually being done. But of course, SPSS is very advanced and it gives us the solution at one go. So the next important crucial question is stepwise always right? A stepwise regression is it will typically not result in the best set of independent variables and could even result in selecting none of the best independent variable. Like in our case, we knew that faculty interaction had high correlation with years of graduation, but it was not selected. In the last step, model number 5, it was actually removed. So the order of variable entry based on the absolute values of the t statistics can be important if any of the independent variable are correlated with each other. The relative amount of variance in the criterion variable explained by each of the independent variable can change drastically when the order of the entry is actually changed. For an example, let's say you are having a basketball team of 5, where the first is picked. The first pick is the best potential player, and of course you have 5, you need to select 5 and you will select the best player based on their previous performances. Then in the context of the characteristic of this player, you will pick the second best potential player, and then the process goes on and on until you select all the 5 players. Alternatively, 5 potential players which play together best as a team are selected. So this is the scenario of the stepwise regression. But this is another option maybe a coach who knows their team well can be doing, because playing together comes into the context. Will the stepwise regression include such a variable? In ours, maybe we didn't include that criterion. So the team that is picked via this method might not have any of the players from the stepwise picked team and could also perform much better. So these are the problem that you will face. Only believes on the stepwise method. What is unique about stepwise regression? It provides an objective screening procedure for independent variable in developing a predictive model of ours. As a conclusion, selecting the appropriate statistical tool for analysis is purely dependent upon the intended use of the analysis. Practical consideration in the selection of independent variable actually can vary. It depends on the researcher's aim, the amount of resources that is available to the researcher, and during which time the frame of your reference being studied. So clearly it is not possible to develop a systematic selection method that would take such consideration into account, and that's why you have many more other models that is available. Thank you. Hope you have benefited from this